Hi, I'm Bruce, and welcome once again to my Colorado Rocky Mountain Lab. Today I've got an Analogic model AN3100 voltage standard. It's a DC voltage standard. It's got 5 decades of control, push-pull vernier, and we'll go positive or negative in the voltage. The unit is in decent looking condition. The cabinet's been resprayed, so of course that looks good. The front panel has some abrasion marks around the switch for polarity, and the stripe has been touched up to hide some of the scratches, but generally it looks very, very nice. And we're going to go through and give it a little test here and just see how it performs. This kind of a voltage standard would be utilized to calibrate voltmeters, oscilloscopes, power supplies, anything that puts out a voltage that you need to calibrate. And works from about 11.1111 volts down to 100 microvolts anyway. All right, we've dimmed the lights so we can more easily see what's going on the standard and on the meter here. Right now we are reading 9.49s on the standard. We've got 9.39s and an 8 on the meter. This is deliberate. We calibrated it this way because it gives us the best curve. As I proceed, you're going to see what I mean by that. Let's go ahead and turn the 9 to an 8. We have 8 and 4/9s on the standard, 8 and 4/9s on the meter. 7 and 4/9s on the standard, 7 and 4/9s on the meter. 6 and 4/9s on the standard, 6 and 4/9s on the meter. 5 and 4/9s on the standard, 5 and 4/9s on the meter. 4 and 4/9s on the standard, we've got 4.9998 on the meter. 3 and 4/9s on the standard, 3 and 4/9s on the meter. 2 and 4/9s, both standard and meter. 1 and 4/9s, standard and meter. 4/9s on the standard, 4/9s on the meter. 0.8 and 3/9s standard, 0.8 and 3/9s meter. 0.7 3/9s standard, 0.8000 on the meter. 0.6 3/9s on the standard, 0.7 and 3/0 on the meter. 0.5 3/9s on the standard, 0.6 and 3/0 on the meter. 0.4 3/9s on the standard, 0.4998 meter. 0.3 and 3/9 standard, 0.3998 meter. 0.2 and 3/9s on standard and meter. 0.1 and 3/9s standard and meter. 0.039s standard and meter. 0.08 and 2/9s standard and meter. 0.0729s standard meter. 0.06 and 2/9s standard and meter. 0.05 and 2/9s standard and meter. 0.04 and 2/9s standard and meter. 0.03 and 2/9s standard and meter. 0.02 and 2/9s standard and meter. 0.01 and 2/9s standard and meter. .0099 standard and meter. 0.0089 standard and meter. 79 standard and meter. 6.9 millivolts standard and meter. 5.9 millivolts standard and meter. 4.9 standard and meter. 3.9 millivolts standard and meter. 2.9 millivolts standard and meter. 1.9 millivolts standard and meter. 0.9 millivolts standard and meter. 0.8 standard and meter. 0.7 standard and meter. 6 standard and meter. 0.5 millivolts standard and meter. 0.4 standard and meter. 0.3 standard and meter. 0.2 standard and meter. 0.1 standard and meter. 0 both standard and meter. Now, we go to figure out the error on this, and we're going to be looking pretty darn good. We'll run it and determine how we stood here. Okay, I ran the performance check, and as we went from 9 and 4/9 all the way down to all zeros, we had 1, 2, 3, 4, 5. We had 6 points that were not all zeros in error. And in those 6 points, the maximum error, now this is error, is 0.025%. So we'll round it up and say 0.03% max error, and that was at 0.3999 volts. We had 0.3998. Other than that, every point that was on here was zeros in error, all the way down to 0.1 millivolts we had 0, and at 0 we had 0. So performed very well. There's a little squiggle. We varied 0.1 millivolts between 0.7 and 3/9 and 0.3 and 3/9. Had a little squiggle in there where we went from a positive to a negative, but our maximum error is 0.025%. Yeah, nice looking unit, performs well. I'm going to thank you for listening, and happy bidding, huh?